Everything you have ever touched, tasted, or breathed is made of the same handful of ingredients. Today, we name every single one, all 17. Welcome to HQRS. Start with something ordinary, a drop of water. Zoom in, and it breaks into molecules. Zoom in again, and each molecule breaks into atoms, 2 hydrogen, 1 oxygen. Zoom into a single atom, and almost everything you see is empty space, a cloud of electrons, orbiting a nucleus 100,000 times smaller than the atom itself. That nucleus is protons and neutrons, packed together by the strongest force in nature. Zoom in one more time, into a single proton, and this is where it gets strange. A proton is not one thing, it is 3 quarks, 2 up quarks, 1 down quark, held together by particles called gluons. A neutron flips the ratio, 2 down, 1 up, but up and down are only the beginning. There are 6 quarks in total, in 3 generations. Let's meet each one. Up and down are generation 1, the only quarks light enough to survive inside ordinary matter. Up carries 2/3 of a positive charge and weighs about 2.16 megaelectronvolts. Down carries 1/3 negative, at about 4.7 megaelectronvolts. Every proton and neutron in your body is built from just these 2. Generation 2 is heavier and far rarer. Charm carries the same charge as up, but weighs almost 600 times more, 1.27 billion electronvolts. Strange carries down's charge at about 93.5 million electronvolts. Outside of particle collisions and cosmic rays, both decay away in a fraction of a second. Generation 3 is the heaviest matter in the standard model. Bottom weighs about 4.2 billion electronvolts. And top, the heaviest fundamental particle we know of, weighs 173 billion electronvolts, heavier than an entire atom of gold. It is so unstable that it decays before it can even bind to another particle. Here is the part almost nobody expects. Add up the mass of a proton's 3 quarks, and you get barely 1% of the proton's actual mass. The other 99% is not made of anything. It is pure binding energy from the gluon field holding the quarks together. Most of your mass is not stuff, it is energy. Now zoom into an electron. Push the most powerful colliders on Earth to their limit, and it never breaks apart. As far as every experiment we have ever run can tell, an electron is a point, fundamental, with no smaller pieces inside it. Electrons belong to a second family, the leptons, and just like quarks, there are 6 of them, in 3 generations. Generation 1 is the electron, negative charge, 500,000 electronvolts, paired with its neutral partner, the electron neutrino. That neutrino weighs less than 0.8 of an electronvolt and barely interacts at all. Trillions of them pass through your body every single second, and you never notice. Generation 2 is the muon, essentially a heavier electron, about 200 times its mass, unstable, decaying in roughly 2 millionths of a second, alongside its own partner, the muon neutrino. Generation 3 is the tau, the heaviest lepton of all, over 17 times heavier than the muon, and actually heavier than a proton. It survives for less than a trillionth of a second. Its partner, the tau neutrino, completes the set. Quarks and leptons, 2 families, 3 generations each, heavier copies of the same pattern, stacked on top of each other like nature wrote the same sentence 3 times. Put it all together, and this is the complete list of matter. 6 quarks, 6 leptons. Every atom, every molecule, every one of us, built from just 12 particles of matter. Those 12 particles only interact because something carries the force between them. 4 carriers in total. Let's meet each one. The photon carries electromagnetism, massless, chargeless, able to travel forever, which is exactly why light reaches us across billions of light years. The gluon carries the strong force, locking quarks together. Also massless, but it comes in 8 color combinations, and a lone gluon has never once been observed on its own. The weak force is carried by the W and Z bosons, and unlike the other 2 carriers, these are heavy. The W weighs about 80 billion electronvolts, the Z about 91 billion. That mass is exactly why the weak force barely reaches beyond the nucleus, and it is what powers radioactive beta decay and the very first step of fusion inside the sun. And in 2012, at the Large Hadron Collider, physicists finally caught the particle that explains why any of this has mass at all. The Higgs boson, measured at 125.2 billion electron volts. Conferred. Measured. Real. But this picture is not complete. The standard model cannot explain gravity. It cannot explain dark matter, or dark energy, or why the universe is made of matter instead of equal parts matter and antimatter. The deepest zoom we have ever taken still ends in open questions. 6 quarks, 6 leptons, 4 scarying bosons, 1 field that gives it all mass, 17 particles, that is the entire universe, reduced to its simplest working parts, and you are made of every single one that matters. Stay curious. Follow HQRS for science like this every single day.